Okay, so this first section that we're going to do has to do with introduction to matrices. So there's a lot of vocab here. So what we're going to do is we're going to define what a matrix is. Okay, so a matrix is what's known as an array of numbers. Okay, and it's basically a grid. So we say matrix A, capital letter, and then it will have different entries. So we're just going to make this super simple. We're going to do like first entry is 10, second entry is 12, then 15, then we'll do like -1, 0, and 2. Okay, so each entry in a matrix is called an element. Okay, now, um, so and matrices are can be any size as long as they're rectangular. Okay, so matrices are classified by their size. Well, actually, the better way to say it is by their dimensions. Okay, so their dimensions are given by the number of rows by, and we put a little x there for by, okay, the number of columns. Okay, rows are side to side, columns are up and down. So matrix A right here is 2 rows by 3 columns. Now, we can talk about the matrix as a whole as a 2 by 3 matrix of matrix A, or we can talk about each element. Each element has a location. Okay, these locations are actually really important because when we start doing operations with matrices like addition and subtraction, you do need to keep track of what you're doing by location. Okay, so I'm going to rewrite matrix A with some variables, and I'll tell you what those variables mean. Notice I'm using a lowercase a. Oops. Okay, so the lowercase a indicates that you're looking at a element of matrix A uppercase. The little numbers on below on the subscript represent the row number and the column number. So this guy right here literally means the element of matrix A located at row 1, column 2. Okay, and looking at the original matrix that I wrote above, that element is actually equal to 12. Okay, the location doesn't actually have to do anything with the value. Okay. So let's try a couple of these out. So for example, here's matrix B. And I really like using graph paper for these and color coding and things like that. So first question, what are the dimensions? So what do you think? We're going to go row by column. So this would be 3 rows by 2 columns. Next question, identify the following elements. Okay, so let's do lowercase b, 2, 2, 3, 1, 1, 2, and 1. Okay, so again, what you're going to do is you're going to use these little numbers. So it's row 2, column 2. So row 2, column 2 would be -1. Row 3, column 1, 3. Running out of colors. Row 1, column 2. And then row 1, column 1. Okay, so that's okay. That's not too bad. Matrices are kind of fun. They are new, so they are going to take a bit of time for you to get used to. Okay, so let's talk about some special instances. These were both rectangular matrices. So let's talk about a square matrix. Okay, a square matrix is exactly what it sounds like. Okay, so that means we have an equal number of rows and columns. So we could have a 1 by 1 matrix, which would just be a single number like this, and those do exist. We have a 2 by 2. Okay, 3 by 3. Okay, and all the way up to 4 by 4, as big as I want. Oops, that's not 3 by 3. I forgot a row. There we go. All right, and as big as I want. Now, all of these matrices have what we call a main diagonal. Okay. Now, this main diagonal is going to become really important when we start talking about something called the identity matrix. Okay, so the main diagonal starts from the upper left and diagonals all the way down to the lower right. So the main diagonal for this guy would be this one. And for a 1 by 1, it's not very interesting. Okay, so that's what's called the main diagonal. Again, this lesson is mainly vocab. Okay, now let's talk about some things we can actually use these for, and we'll kind of use them a little bit more later on. Again, this is vocab. So to have equal matrices, the matrices must be the same size. So a 2 by 2 can be equal to another 2 by 2, but it can't be equal to a 3 by 3. Okay? So if I say matrix A, and let's say that's 15, 12, 10, and negative 2, is equal to this matrix, okay, the elements must also be equal. Okay? Oops, forgot the yes. Okay. So those two matrices, both 2 by 2, have to be equal. So let's chat. Let's see if we can use this to help us out. Can we use the idea of equal matrices to find the values of A and B? Okay, so we're just going to match. Elements match up with elements. So 2A should be equal to 6. Okay, and then negative 7B should be equal to negative 21. And very uncreatively on my part, they're both 3. Okay? All right. So that's kind of one of the ways that we can use matrices. Another way to use matrices, and we'll get more into this later on, is using it for linear systems. Okay, so way back when in math, maybe 1, math 8, you guys hopefully ran into something that looked like this. Okay, and you use graphing, you use substitution, you use elimination to solve. But when these get larger, okay, we can write them as a matrix. So we have what's called a coefficient matrix. Which is simply a matrix of all the coefficients. Okay, and then we have what's called an augmented matrix. And I'm going to show you how Edgenuity does it, and I'm going to add something that kind of visually helps out, but Edgenuity doesn't do it. So they'll start out with the coefficients. So 3, 5, 2, 4, and then next to it, after what happens to the right of the equal sign, they'll write this. So that's considered an augmented matrix. Now, Edgenuity and most math textbooks don't put anything visually to indicate that equal sign. I tend to put just a few dots just to let me know where that equal sign is. It's just a nice visual representation of that equal sign. It's not required, but it does help me out a lot. Okay, Again, this is an introductory section, so not too bad. Okay? If you have any questions, let me know.